Hello everyone, in this video we are just going to interface 16x2 LCD in 4-bit mode with the Renesas RL78F14 series microcontroller. Let's get started. So as the first step, let us try to understand the schematic diagram that we are going to build for interfacing this LCD in 4-bit mode with our RL78F14 series microcontroller. So I hope we discussed this particular circuit diagram for interfacing the LCD in 8-bit mode with our microcontroller in the previous one of our interface video. But in this video, as I mentioned, we are just going to interface the same LCD in 4-bit mode, that is 4-bit data mode. So for that, the only difference is that we will be neglecting the LSB data lines connection from this development board. So the connections of the data lines such as D0, D1, D2, D3 will be neglected, and we will be connecting only the D4, D5, D6, D7 data lines connection to this development board. So the rest of the connections are common. Only thing is we will be neglecting the D0, D1, D2, D3 connections to this development board. Other than that, we will be connecting this VSS to ground of the development board, VDD to positive rail of the development board, and VEE to the potentiometer for varying the contrast of the font available in the LCD. And anode, that is the 15th pin of the LCD, will be connected to VDD through 10 kilo ohms resistor, and 16th pin of the LCD will be connected to ground of the development board. And RSRW enable will be connected to P72, P70, P32. That is connector pin number 40, 45, 47, 49. And D4, D5, D6, D7 will be connected to connector CN1 pin number 35, 37, 39, 41. And following 43rd pin is the ground of the development board. So I will be connecting this particular pin to the ground of the LCD, and this particular pin, that is pin number 25 of the CN1 connector, is the VDD of the development board. So I will be utilizing this particular VDD terminal of the development board for powering up the LCD. So I hope you remember the schematic explanation that I have done for interfacing the same LCD in 8-bit mode to the same development board. I hope you watched that before watching this video, so that would also help you in better understanding. So I hope I explained you this particular schematic in detail. Now let's move on for further configuration of the microcontroller for interfacing this particular LCD with our microcontroller in our CubeSuite Plus software. So now let us try to open the CubeSuite Plus for CCRL IDE for creating our project for the microcontroller. You can see in this IDE opened, I'm just going to create my new project. Just click on the project tab in the top of the window and then hover over this create new project and click on it for creating your new project. And in the window that is popping out, just type in the microcontroller name. In my case, I'm just typing R5F10 PPJ, and you can see the highlighted microcontroller will be selected by default. So just cross verify that the pin number is correct for your microcontroller. In my case, it is 100 pin, it is correct. So I'm just leaving it. Or if it is anything different like this one or this one, just click on select anything as per your requirement. Just left click and select it as per your requirement. And once after selecting the microcontroller, just provide a name for your project in this project name tab. I'm just providing it to be Pro. And in place of this place tab, just click on this browse button for selecting the repository or directory in your local folders where you want the project to be stored. So let me just make a folder right over here, RL78. And I'm selecting that folder and I'm clicking on the create button for creating my project for this particular microcontroller selected. You can see on the left of the IDE we are having a particular tab called project tree. So this particular tab will be containing several segments of the microcontroller. Those are very important. First and foremost segment is the pin configurator segment, and next segment is the code generator segment, and the next segment is the file segment. So these three are the major segments that is generated for your microcontroller. So this pin configurator segment is useful for visualizing the configurations that has been done for your particular microcontroller. So when I double click on this device top view, you can clearly see this is the layout diagram of my microcontroller RL78 bar F14, that is R5F10 PPJ. You can see each pin description has been provided right over here. Once the configurations is done, you can see the configurations that has been done as a whole in this layout. So for that purpose, this pin configurator has been provided. So using this code generator segment right over here, you will be able to generate your own base peripheral software that is required for your microcontroller as per your user application. So I will be showing you how to configure your microcontroller in a while as per your application needs. But before that, we just want to do some basic configurations that needs to be done for almost all the programs. Just double click on this clock generator tab inside the code generator, and you can see these configurations, that is the default configurations that needs to be fixed in the microcontroller before moving on. So let's take an example. This particular PIOR00 is yet to be assigned to the function TI00, and the respective port pin for that function is P17 by default. So if you need any alternate port pin to be configured for this function, let's check it out. Just click on this drop down. You can see the alternate pin that can be assigned with the same function is P66. So if you want that particular pin to have this feature, you just want to select that. So most often we will not be changing anything right over here. We can use all these functions for all these pins as it is. So if in case anything is required, I will just intimate you in future lecture videos. But for now, we will be fixing these settings by default. Just click on fix settings for fixing these settings as default settings in this microcontroller. Once that is done, just click on chip debug settings tab right over here. And this is a tab which is useful for enabling the debug option in your microcontroller. So if this is disabled, you will not be able to program your microcontroller using debugger, or you will not be able to debug your microcontroller using debuggers like E1, E2, E2 Lite, etc. So for that, just click on used radio button right over here. In my case, I'm just going to select the E1 right over here. If you are using any other emulators like E2 or E2 Lite, you just want to select the respective radio buttons right over here. So in my case, I'm just leaving this to be E1 selected. That's all about the basic configurations that you want to do. In addition to that, just double click on this watchdog timer right over here in the project tree inside the code generator, and you can see by default this watchdog timer is enabled, or it is used by the code generator. So you just want to disable it. So I will teach you what is this watchdog and how to configure this watchdog in this microcontroller in a separate video. And for now, for almost all the videos, I will be disabling this watchdog, and in a separate video we will learn how to enable the watchdog and how to utilize its features for safeguarding our microcontroller. That's it. These are all the required basic configurations that you want to do for almost all the programs. So now let's just move for configuring our microcontroller as per our application needs. So this is the same program which we wrote in the lecture of interfacing the same 16x2 LCD in 8-bit mode with the RL78 bar F14 series microcontroller. So we are just going to alter this program a little bit for interfacing the same LCD in 4-bit mode. So we very well know that these are the pins required for interfacing LCD in 4-bit mode. We just want to configure all these pins as output pins from the schematic. But in 8-bit mode, we utilized extra 4 pins from D0 to D3. So we just want to remove these configurations. That is, we just want to undo these configurations that we did in interfacing the same LCD in 8-bit mode program. So I will be using, or I will be disabling these configurations as unused pins in that configuration, that is P63, 65, 67 and P155. So I'm just closing this main and coming to the code generator. Click on the plus icon near code generator and double click on this port. and come near this port 6 and click on it. So you can clearly see we have configured all these pins as output for interfacing the LCD in 8-bit mode. So I'm just going to click on this unused button near all these pins. And in addition to that, we are just going to disable this particular configuration also. That is P155 would have been also configured as output pin. So come to the port 15 and unuse the P15. That's it. Now just click on this generate code for generating the required configurations for your project. That's it. Now open the main.c or main.c. And as the first step, you can clearly see we will not be utilizing bits from 0 to 3. We will be utilizing only the MSB bits for interfacing this particular LCD in 4-bit mode. So in this print data function, we will be deleting the configurations for bit 0 to bit 3. This is the first change that we have made for interfacing this LCD in 4-bit mode. And coming to the data register, since we are not having LSB 4 bits and we are having only MSB 4 bits available, for passing a byte of data, what we will do is we will just pass the MSB of the byte of data first, and then we will move the LSB of the byte to the MSB section, and then we will move that particular LSB section of the byte to the MSB data lines. So you can clearly see, let's assume an example for understanding this. Let me just zoom in a little bit. So just assume that we are passing a particular number. Let's take it to be 1. So if you pass 1 like right over here, which is nothing but 0x31 in hexadecimal. That is the ASCII representation of this number. So as the first step, when you perform this operation, what happens is, since the MSB data lines is only the available segment in our print data function, what happens here is this 0x3 will be passed and this 1 will be neglected. So as the next step, what we will do is we will again perform the same operation with the LSB data. Notice here what we will do is we will just pass char data of left shifted by 4 times. So when you perform this left shifted by 4 times, what happens here is this 0x31 is nothing but 0011 0001. So this whole binary data will be left shifted by 4 times. So this 1 will be coming to the position of 1, 2, 3 and 4, and these 4 bits will be removed from the byte. So what happens here is the data that I will be having is 0001 0000. So you can clearly see the LSB of the byte has now been available in the MSB segment of the byte. So since we are having only the MSB data lines, we are just moving or voluntarily moving this LSB of the byte to the MSB segment of the byte, and then we are passing that to the print data function, so that that particular 4 bits of data will be also passed to the MSB data lines of the LCD. So this is the 4-bit method. That is, in an 8-bit method, we will be passing a byte of data as a whole to the 8 bits of the data lines of LCD from the D0 to D7. But in 4-bit mode, we will be passing a byte of data into the data lines twice. Once we will be passing the MSB of the byte, and later we will be passing the LSB 4 bits of the byte. So that's it. In the same manner, I am just performing the same operation for this command function also. As the second step, I will be passing command left shifted by 4 times. And in the LCD initialization segment, or in the LCD initialize function, I will be passing first command to be 28. So this will be configuring the LCD in 4-bit mode, utilizing 16 columns and 2 rows of the LCD. That's it. So this particular program will be helpful for interfacing the LCD in 4-bit mode with our Renesas RL78F14 series microcontroller. So let me just build this program by clicking on F7 in your keyboard or this particular icon right over here. You can see I got 0 errors and 0 warnings. Now I'm just connecting my E1 emulator to the PC USB port. Now for dumping the program to the microcontroller development board, make sure that you select the emulator tool properly. Just right click on this RL78 debug tool icon right over here and hover over using debug tool and select the required debug tool. In my case, I'm using E1, that's why I have selected E1. If you're using E2 or E2 Lite, you just want to select accordingly. So you can clearly see I have already connected my 16x2 LCD in the breadboard. So as per the circuit diagram that I have already discussed in this video. So this VSS pin is connected to this rail. You can clearly see this black wire is connected to the VSS pin, which is the ground of whole LCD, and the VDD pin is connected to this rail, that is the top rail, that is the red wire. So I can utilize this rail in the breadboard for powering up the LCD and the second rail in the breadboard for providing the ground for the LCD. And you can see the potentiometer is connected right over here. This is a 10 kilo ohms potentiometer. You can see the value 103. And further you can see RS RW enable D0, D1, D2, D3, D4, D5, D6, D7 is connected to respective jumpers. And other end of the jumpers I will be connecting it to the microcontroller pins as per the circuit diagram already discussed in this video. And coming to the extreme end of the LCD, that is the 15th and 16th pin, you can clearly see 15th pin, that is the anode of the backlight of the LCD, is connected to 220 ohms resistor, and the other end of the resistor is connected to 5 volt rail of the breadboard. So this is the power supply rail, and cathode is already connected to ground of the circuit. You can clearly see this is the ground rail of the breadboard. That's it. Now let me just connect all these respective terminals to the GPIO pins as per the circuit diagram that I have already discussed in this video, and then let's see the output in the hardware. And the only difference between the 8-bit and 4-bit mode connections are we will not be utilizing these 4 LSP bits, that is the D0 to D3 lines. We will not be utilizing these lines. So let me just remove these 4 lines. And now let us try to make the connection between these available lines and the GPIO terminals of the development board that we are having, that is the RL78 development board of the Renesas microcontroller, for visualizing the output in the hardware. So for dumping the program, just click on F6 in the keyboard or this particular icon in the top of the IDE. You can see the program is being downloaded to the microcontroller. So for running the program, I just want to click on this execute button right over here, that is the play button highlighted in green. Program has started execution successfully. So as you can see on the screen, the schematic, I have already built this particular schematic in the breadboard. You can clearly see this is the schematic that I have built, and this is the output that I got in the hardware. That is embedded has been printed from the first row first column of the LCD, and system has been printed in the second row first column of the LCD, from the second row first column of the LCD. That is the same output that I got in the 8-bit mode. Since we have not altered anything in the program, just we altered the program for interfacing the LCD in 4-bit mode. That's it. You can see the data lines from D0 to D3 are removed in the schematic circuit built, and using this particular potentiometer right over here, you can vary the contrast of the font available in the LCD. So I hope you understood the method of interfacing the 16x2 LCD in 4-bit mode with the Renesas RL78F14 series microcontroller in this video. See you in the next video. Thanks for watching.